What's going on, everyone? This is Raheel and welcome to this video. Today I'm going to be looking at some common functions that are within the built-in math module inside of Python that can really help you make your code look clean, consistent, as well as help you code faster overall. If that's something that you think you're into, then this video is definitely for you. Without further ado, let's get straight into the functions. So the first section I'm going to be starting off in is constants. Essentially, we have numbers that we can reuse throughout most formulas, such as pi for circumferences and diameters in circles, or Euler's numbers for logarithmic algorithms, I believe. And then, of course, there's infinity, not a number, and all sorts that are available to us within the math module. Of course, it would be a little tedious to type these all out ourselves. Let's say if I were to go into the this code editor right here and type in the value of pi, so that would be like 3.14, and then you just keep on going and all. And that might take a while in terms of precision, so we can actually just access the variable that's given to us built into Python, of course, in the math module. So I can just do from math import, I can't type today, import pi, and let's say I want to print pi. So this will just print out all of the values of pi that are available within the math module inside of Python, which is pretty cool. Another one, for example, let's just say is nan. Of course, I'm just importing this from the math module here. Nan just means not a number, which is just another word for a non-numerical value or an invalid numerical value. And you might see this in lots of databases, but that's essentially all that's going to be. You can see that it's just printed nan right here. So pretty good for comparing if something is a number or not a number. It's its own little data type, I'd say. There's lots more, of course, infinity, Euler's number, like I already mentioned. So there's plenty of all available to you. Be sure to check those out in the description, where I have the whole math library or the math module available for you to explore. So the next section is going to be arithmetic in terms of the math module. These are going to be its own little functions that are going to be converting inputs into outputs, which is a bit better than just these variables that I showed here. So what I'll import here is, let's say, the factorial function. So yes, you can take a factorial in the math module, which is pretty sweet. We can also import the ceil function, the floor function, as well as square root. If you want to take the factorial of a number, of course you can build your own algorithm. Of course, this algorithm is a little longer than it needs to be, but the point is that we can shorten this up entirely and just avoid writing this whole thing just by using the factorial function that's in the math library. So if I just write that, then it'll still get 120. The next thing we'll be looking at is rounding. So essentially, if you wanted to round a number off in Python, of course, the most obvious option would just be to convert the float to an integer, but that means that 2.9 gets converted to 2, so that it always goes to the very bottom instead of rounding to the top. In the math library, you can actually just use ceil and floor to directly control where it rounds off to. Does it round to the top or the ceiling, or does it round up to the bottom, round down to the bottom, or floor? So I'll show you an example of this. If we have the number 2.9, so just do 2.9, and I want to print the ceil of that number or the floor of that number. So the first result should always be 3, and the second result should always be 2. If we run that, and you can see the first result is 3, and the second result is 2, as expected. That's pretty nice to know in terms of rounding. Definitely use the math library when it comes to this, because it makes your code a little more semantic, a little more readable, a little more clean. And the last one in this arithmetic operations are going to be square root. Of course, if you want a square root in Python, this is probably going to be the most easiest way I've seen so far, where you can just put in your number inside of the square root function, such as, let's say, 25, which should output 5. So if I do print the square root, then we should just get 5.0. And the last section I'm going to be covering here is going to be trigonometric functions. So if you want to do sine, cos, or tan, those are all available in the math library and are all very readable. You don't have to do any custom operations with them if you don't want to. So I'm just going to import them here. Sine, cos, and tan. Those are all going to have their own functions that we're going to be using. And if I want to just encapsulate those in one trig function, I might as well give it a go. So we got to supply these functions with an angle, and I'll just in one line return the sine of that angle, the cos of that angle, and lastly the tan of that angle. So if I type that down, oh, I actually have to supply a number. So I'll supply an angle of 45 degrees. So let's try that out, print the result, see what that looks like. And of course, these numbers are going to be really low. Let me just change it up to a much higher number, maybe 120, and you can see that these are still giving us some good decimals. So as you can see, those calculations are in fact working. So those are all of the functions I have in this video. Of course, these are just the common functions. There's lots more functions available in the link in the description, which is going to be the actual Python math library documentation. Those functions can handle complex numbers or imaginary numbers combined with real numbers, which is really advanced, logarithmic functions, graphing, on lots more. And there's also third-party math libraries in Python, such as NumPy, which handles arrays that are very complex, and lots of functions for that as well. If you found this video helpful at all, be sure to drop a like down below and comment on what functions you use the most in the math library. As always, thanks so much for watching. I'll see you guys in the next video.